Hi, I am Abhinandan Bhattacharjee. I am a PhD student at IIT Kanpur, and today I will present a video on the strategy or the preparation of quantum mechanics in CSIR NET exam. And in this video, you'll find the topic-wise analysis as well as the book suggestions for quantum mechanics. And this is basically the strategy that I have followed during my preparation and which gave me a kind of a decent rank. So I'll basically share my experience through this video. So let's begin. So why quantum mechanics? The first question that comes to your mind, or you must wonder why this person choose quantum mechanics. There is a very important reason behind it, and I will clarify that. In CSIR NET, there are basically two types of questions. One is the section B, which contains only 3.5 marks questions. In that section, you will find each question of 3.5 marks. And there is a section C in which you will find each question of 5 marks. So these are the two sections from physics. The other section is general awareness. So these are the two sections of physics. And if you look at the number of questions that comes from quantum mechanics in these two questions are, so in 3.5 marks section, you can expect at least around 5 questions. And in the 5 marks section, you expect at least 3 questions. So these are the numbers that I got. These are the average numbers that I got from the past year question analysis. So these are the kind of authentic numbers. And if I add all those numbers, that means you can expect at least 32 to 37 marks from quantum mechanics only, and which is basically the 40 to 50% of the cutoff of this exam. And this is the very important information regarding how to make a strategy for this exam. Now, if you read only quantum mechanics, you are done with the 50% or more than 40%. So with this information, it is very important to prepare quantum mechanics very thoroughly. Don't skip quantum mechanics. It will give you 40%. Like, it's the only one topic which keeps giving you 40%. So let's not miss it, and let's prepare it very thoroughly. So I will present a topic wise analysis for that, and let's see which topic we need to prepare, which topic we need to look very thoroughly. So let's go through that process. So first topic is the very popular one-dimensional box. So it's the infinite well potential one-dimensional box. And from that topic, you can expect at least one question in the 3.5 section. Like every year, you'll find at least one question. And some year, you can find a 5 marks question, which is very good thing, because if you find a 5 marks question from 1D box, you can easily score that 5. So now I will present few sample questions from the past year exam. So I just took randomly few questions from the exam just to show what type of things they may ask you. Oh, before that, so in total, we can expect 3.5 to 15.5 from 1D box. So 15.5 is too much, but at least you can expect more than 3.5 only from one-dimensional box. If you know properly one-dimensional box, you can solve at least 3 to 7 marks. Now I'll present those questions. So this is the first question. If you look at this question, this is a wave function they have given for a 1D box, some wave function. And for this wave function, one is to figure out what is the expectation value of energy. So this type of questions they may ask. They may give you some arbitrary wave function, and they may ask you what is the corresponding expectation value of energy. So you need to know how to solve this type of problems. This problem is also very similar. Here also they have given an arbitrary wave function for a particle in a box, and they are asking that what is the probability for that particle to live in the ground state, or to live with the ground state energy. So what is the probability that you will find the particle at the ground state for this given wave function? So these two questions are quite similar, but there is just a little bit difference. One is finding the probability of ground state, the above one is finding the expectation value of energy. So a little bit different, but you can get what type of questions they may ask you. And this is the third type. So instead of 1D box, they may ask you 3D box, which is the extension along y direction and z direction. And for a 3D box, you find some degenerate energy level, and they may ask you how many energy states are there. So these are the type of questions that I find in the previous year exams. There are few other type of questions you will find, but don't worry, we can solve all those questions just by going through Griffith's chapter number 2, section 2.2. So if you go through this section, read it properly, solve most of the questions from this section, you will guarantee that you can solve all the questions of 1D box in any exams, either it's net or gate or chest. So just go through this section, read it thoroughly, solve most of the problems. You can, whatever the idea that you will get, or whatever the concept you can develop, that will help you everywhere. So let's move to the next one, the harmonic oscillator. In harmonic oscillator, we can expect at least one question again from 3.5 or two questions. And sometimes you may find one question from 5 marks sections. So this is another mandatory topic. So in 1D box, we find at least one question will come. Here also you'll find at least one question will come. So if you prepare both of them, you can score 7 minimum. Now let's go through the questions. What type of questions they may ask you. Okay, sorry, before that, you can expect at least 3.5 to 12 marks from harmonic oscillator. So 12, if you get, it's very good, but at least you will get 3.5 to 7 in most of the years from harmonic oscillator. So next is the question. So one common question they typically ask everywhere. So for a ground state or the superposition of ground state with some excited state, what is the uncertainty in momentum? What is the uncertainty in position? And to solve those questions, one very nice trick is the use of annihilation and creation operator. So if you know how to utilize annihilation and creation operator, these questions are basically a piece of cake. So just go through that annihilation and creation operator and you can solve this type of questions. They may ask you, they may give you some uh, state, some arbitrary state, which may be a superposition of lot of 0, 1, 2, 3, and they may ask you what is the expectation value of x, means position or momentum, such kind of things. Next is the, if you extend this 1D harmonic oscillator to 2D oscillator, then you may find some questions regarding the what are the energy levels, what is the ground state energy, what is the first excited state. And since now in the first excited state, so on the second excited state, so you can expect some degeneracy, and based on that they may ask you some questions, and you can find all the answers or you can prepare all the answers just by going through Griffith chapter number 2, section 2.3, and you will find that annihilation, creation and everything there. So just go through this section. That's all. Next topic is kind of like the other type of potentials. So till now we have gone through infinite well, then harmonic oscillator. So there are some other type of potentials like Dirac delta or step potentials. And from that, if you find questions, typically they come in the 5 mark sections. Many times you will not find any questions, but sometimes you may find one odd questions from that one. And these are those type of questions. So this is from Dirac potential, and this is from step potential. This is again for Dirac delta potential. You need to find the uncertainty product. And another point I want to make here, that people may ask you uncertainty product for different type of potentials also, and also for different type of wave functions. So figure out how to calculate uncertainty product for some given wave functions or for some potentials. So that is an important question also. So now for that, you can also go through Griffith 2.5 and 2.6 and go through these sections. You can develop the skills for solving those questions. And as a whole, if you go through chapter number 2 of Griffith, you can cover a lot of things, and that will help you to score a good percentage from quantum mechanics. So let's move to the next topic. which is the formalism of quantum mechanics. And in that, you can expect at least one question from that section, or sometimes it is two in the 3.5. And that section consists of a lot of different topics, like how to find the expectation value of an operator, then operator algebra, then commutation relationships, then evolutions, and all sort of stuffs. And if I just figure out few questions from that, so you can see this is a given operator, Hamiltonian operator, and we need to figure out what is the expectation value of this Hamiltonian for this energy level. So if you go through this formalism chapter thoroughly, then you will know a trick for figuring out expectation value of a given operator, of any given operator for a given physical state. You don't need to do it in a very rigorous way. There are some tricks for that. So just go through formalism chapter in Griffith. Next one is the commutation relationship. Then again, some questions from expectation value for an arbitrary states. And this question is like, you have a state at t is equal to 0, then you evolve that state, and that is based on time evolution. So these are the type of questions that you expect from this section, and at least you can expect it one question from this section in the exam. And the book that you should go through is the Griffith chapter 3. This is the most important chapter, I feel, in the quantum mechanics, to know or to understand how quantum mechanics works, at least in the mathematical way. These chapters are very, very important. So go through this chapter number 3 in Griffith, as well as go through chapter number 1 of Sakurai. Sakurai is a very, very good book. So you must go through Sakurai to understand all those things. It's very nicely done. You'll find a lot of problems in the exercise. Try to solve those problems. And if you solve those problems, you'll become master of this particular topic, at least at the level of NET, GATE, just any exam. So let's move on to the next one, which is the hydrogen atom and angular momentum. So from this section, mostly the question comes from only angular momentum. Hydrogen atom is like the less one. You will find at least one question some year, but mostly you will find every year there are 1 to 2 questions from the angular momentum operator. So this is the thing. So you can expect 3.5 section, you can expect at least 1 to 2. So it's a mandatory, I feel, to read angular momentum. And sometimes you may find some question even in the 5 mark sections from hydrogen atom maybe. And so this is a very important section. So please go through it very thoroughly, because you'll definitely find 1 or 2 questions from this section. And it's a very heavy section. So I'll present some demo questions for this section. So see, there is a given state, which is in terms of NLM. And for this state, one is to find the expectation value or some, whether the state is an eigenstate of L square or LZ. So those kind of things. So this is basically a given state that comes from hydrogen atom. And for this state, you need to figure out the angular momentum stuffs. Next question is, so there is another some Coulomb potential as well as some central potentials are there. So this comes from the hydrogen atom. And if you have that one, then what will happen to the energy level? So go through the hydrogen atom. So from that you can figure out this one. This is again the question, some question from uncertainty product in Lx and Lz, sorry, Ly. And there is a simple trick to that. Like I have mentioned annihilation and creation operator in harmonic oscillator. Here also in case of angular momentum, there are some annihilation and creation operator in terms of Lx and Lz. So if you know those things, you can very easily solve this problem. So these are very simple problems. They may look difficult, but these are very simple. And last one, maybe some commutation relation based on Lx, Ly, and Lz. So these are the type of questions. So one additional type of question that I have missed here is that they may ask you that what is the most probable radius, or they give a wave function for a hydrogen atom, and where at what radial distance the wave function has peaked, or what is the what at what distance you will get the maximum probability of finding in the particle. So some kind of questions are there in the hydrogen atom. So focus on those type of questions, and to solve those questions you must go through this ZTLE. Why I mention ZTLE? Because in ZTLE chapter number 5 angular momentum section, sorry, in ZTLE chapter number 5 in angular momentum section, the type of questions or the type of examples are given that are very relevant to this gate exam or this net exam, sorry, net exam. As well as you can go to the hydrogen atom from that book. And if you want to know angular momentum very thoroughly, then follow Sakurai chapter number 3, that is dedicated to angular momentum only. And if you can follow that, you'll become a master in that section. So let's move on to the next one, which is the spin. So in spin, you can expect one question from 5 or one question from 3.5. And what are the type of questions that I'll tell you? So see, there is a Hamiltonian, and it is expressed in terms of spin operators, and you need to find the eigenvalues for this Hamiltonian. For that, you need to know what is the spin operator, what is the Sx, Sy, and Sz of spin operator, and all those things one needs to know. So this is one type of question. Second type of question is based on Stern-Gerlach experiment. So it's a very important experiment, or a revolutionary experiment in quantum mechanics. So just go through that experiment and try to figure out how to solve the questions based on that experiment. Another problem, if you put a spin in a magnetic field, then for this is the Hamiltonian you will find, and based on the Hamiltonian you need to figure out the expectation value of this Pauli operators. So these are the typical questions that comes from spin chapter in quantum mechanics. In NET exam. So just go through Griffith 4.4 and Sakurai 1.1. So if you go through these two sections, you can handle all these questions. And Sakurai is the best book for spin. So if you want to know spin, you must go through Sakurai. And our next topic is the perturbation theory, which is a heavy topic because you will get minimum one question in the 5-mark section from the perturbation. You may get 2 questions also. And these questions will be very straightforward. They will come from degenerate perturbation or non-degenerate perturbation, and those will be time-independent perturbation theory. So very simple or very straightforward questions. So I'll show some demo. Oh, before that, we can at least expect more than 5 marks for the perturbation theory if we know how to solve perturbation problems. So there is a like 1D box potential. Now, if you give some perturbation to that potential in the area, this is the perturbation, and for that, how much the energy level will change, so that you need to figure out. Next question is also very similar. Instead of a 1D box, you have a hydrogen atom, and if you give some perturbation, what is the change in the ground state energy? This question is also quite similar. So this is the extra perturbation that you are giving to a harmonic potential, and because of this one, what is the change in the energy level? So these are the different questions that you can expect in the exam from the perturbation. And these are the questions I only gave from the non-degenerate perturbation theory. You may expect some question from degenerate perturbation theory also, so that I have missed to include here, but you must go through. And if you go through Griffith chapter number 6, only section 6.1 and 6.2, you are done. Because in these 2 sections, you will find how to figure out non-degenerate perturbation and how to do degenerate perturbation. So if you figure out these 2 sections and go through it, solve the problems, you can definitely get a 5 or 10 marks from this section in net, guarantee. My last topic is WKB approximation. So I have added few topics here because I find it not so relevant to explain them separately. So one is the WKB approximation, another is the scattering theory, another is the variational principle. So if you add these three topics together, at least you can find 1 to 3 questions in the exams. Minimum one, when most of the times you will encounter with 2 questions, so 10 marks. So and those questions will be very straightforward. You just need to remember some formula and your job is done. So I'll show some demo. So in scattering, you will find some Born approximation. So if you go through a scattering theory chapter, you'll find Born approximation. And for that Born approximation, you just need to find the scattering cross section. So there is a formula for the scattering cross section, which consists of some potential. So you need to put the potential, do some integration, you are done. So very straightforward, and you will get 5 marks. Next is the WKB. So WKB approximation helps us to figure out the energy levels for a given potential. So this is a trick to figure out energy levels for complicated type of potentials. So here they have also given some helping formula. So if you go through WKB chapter, I will tell you that there are certain stuffs you just need to look at, and those things will only come in the exam. And next is the variational principle. So variational principle is a trick to figure out the ground state energy for a system. And so this is a given potential, and for this potential you are finding using variational principle to find the ground state energy. So this is also very straightforward stuff. So now let's look at what to read for this one to score at least 10 marks from this section. So go through Griffith chapter number 8 for WKB. There are few problems like example 8.3 or 8.4. Just go through them. You'll find very similar question comes in NET exam. For scattering, I just wrote first Born approximation because this is the most important thing from the scattering chapter, and you will find almost every year there is a question from Born approximation. So go through this 11.4. At the end you'll find a lot of rigorous maths, but at the end you'll find a very simple formula for calculating cross section. So go through that. Also you can look at these two sections because sometimes you may find some question from this section. So don't miss it because you need to just go through these 3 sections, and at the end you will encounter some simple formula. Using that you need to solve the problem, and you can easily score 5 marks. And at the end, the variational principle. For that, just go through Griffith chapter number 7, section 7.1. Just go through section 7.1. There will be some example and you are done. So just go through that example, and similar type of problems you will expect in the exam. So if you go through all those things, you can at least minimum you can score 5 marks. Even most of the times you will get 10 marks from these sections. Now, if I summarize everything, so these are the 3 books. If we go through these 3 books, only those chapters, you don't need to go through the every chapter of these 3 books. You just need to go through these few chapters, mostly from Griffith. So only these chapters you need to go through, or sections you need to go through from these 3 books, and he will become a master in quantum mechanics at the level of NET gate or just exams or the level of problem solving. And if you can do that, your 40 to 50% job is done. So congratulations for that if you can do that. And this is all about quantum mechanics, so don't skip quantum mechanics. This is my suggestion. This is the most important topic for any exam, and if you follow all those things, you will become master in that, and you can score very easily or qualify very easily any exam. So if you find this video useful, so please like this video, share this video, and please subscribe our channel. And thank you for your attention. And if you have any query, please write down in the comment section.